In this video, we'll explore some real-world applications of equations. Now, some suggestions to help you out. First, take time to read the problem through a couple times. Try to determine what's being asked and what could be some potential outcomes for that question. Then see if you can figure out what it is that you're trying to actually solve for and assign it a variable. Look through all the known facts that you have and try to create expressions that could be used with these facts. Then try to piece it together to create an equation that could be used to solve for that specific variable. And then check that solution and see if it works, and also make sure that it would make sense for that to be a potential answer. So here's an example. Say I want to create a bouquet of a dozen flowers for my mom's birthday. The florist is going to charge me $1.50 for each rose and 50 cents for each carnation. If I only have $13 to spend, how many of each flower should I purchase to make the bouquet? And again, there's a couple different pieces there. First, I need to figure out how many roses and how many carnations am I going to put in this bouquet. But what I do know is that I want my total to be 12 flowers. So that limits the combinations that could be made for the price and for the number of flowers I want. So maybe I don't have an idea of how many roses I need yet, so I could say that that's X. That would mean the number of carnations then would have to be 12 minus X, or 12 minus the number of roses I use. I could have done it the other way and made X the number of carnations and then 12 minus X the number of roses. Either way will work, it's just you'll have to simplify a little bit differently, but the solutions will still come out the same. Now, I know that the cost is $1.50 per rose and 50 cents per carnation. Well, that means I'm going to take my $1.50 times my number of roses and 50 cents times my number of carnations. And in this case, that's X and 12 minus X. Now I know that that has to total up to how much I want to spend, which is $13. So I take my expression, set equal to 13, and solve. So I'm going to distribute the 50 cents, and then I'm going to combine like terms, and then when I subtract, I get 7. Well, X, if I remember, is my number of roses right here. So I know I have 7 roses, and then 12 minus X is 5, so 5 carnations. I can check this. So if I plug in $1.50 times my 7 roses, plus 50 cents times the 12 minus 7 roses, that gives me $10.50 plus $2.50, and that's $13. So I spent $13, I got 12 flowers, I did exactly what I wanted to do. In banking, we have different types of interest. One of those is simple interest, where you only pay interest on the original amount that you borrowed, which is called the principal. So the formula that we can use for this to find out how much interest we would pay is I equals P RT, and we're multiplying these three different variables together. So my total interest is going to equal my principal, the amount borrowed, times the annual interest rate, times the period of time in years that I borrow. And in years is the key part. A lot of times you'll get it in months, and you need to make sure you convert it to years. So here's an example. Say Sherry wants to buy a new car. It's $23,000, and they got a special deal where they're paying 1.5% simple interest for 60 months. You're not normally going to get that with a real car dealership. So if you ever see that, take it. If Sherry borrows that full amount, how much will she pay in interest over the course of the loan? So we look at what we know. We know the principal that she's starting with is $23,000. She knows that she has an interest rate of 1.5%, or 0.015, and you want to change it to the decimal value to be able to solve these problems. And then time is 60 months, but again, we're dealing within years. So 60 divided by 12 is 5 years. So if I go through this entire problem and plug in what I know, I have 23,000 times 0.015 times 5. I multiply my three terms and I get $1,725. So she's going to pay about $1,700 in interest over the course of this deal. Now we also will deal with uniform motion type problems, which is where we're looking at objects moving at a constant speed, which we may also see the word rate. This is the formula: distance equals rate times time. D equals RT. So say we have a situation where Ben wants to go out for a bike ride. He's averaging 20 miles an hour in this ride. After 30 minutes, Bailey noticed that Ben left his water bottle, so she drives after him at 50 miles an hour to give him his water bottle. So how long will it take her to catch up, and how far away will Ben be? So in this case, we know we're trying to figure out how long it will take from when Bailey leaves to catch up with Ben. So that's going to be our t value. And I'm going to use a table to help me here just to sort my information I know. So I know I need to figure out my distance, my rate, and my time. Well, Ben was traveling at 20 miles an hour. Bailey was traveling at 50 miles an hour. Bailey is going to take t hours to catch up. Now, if we think about Ben, it's going to take t hours as well to catch up, plus the time it was that he left, in this case 30 minutes. But remember, we're dealing with hours, so that is half of an hour, t plus 1/2. And then its distance is going to equal rate times time. So 20 times the quantity, t plus 1/2, and then 50 times t. Now what you have to remember, though, is that when you catch up, that means that you're at the same place. So these distances have to be equal. So I can set them equal. Now I just solve for t. So I get 20t plus 10. So 10 equals 30t. So that gives me that t is a third of an hour, or 20 minutes. So that means it took Bailey 20 minutes to catch up to Ben. So if I plug that back in, I can then figure out, well, how far away was Ben from the house? So I've got my distance equals my rate times my time. That's going to be the 20. I'm going to plug in the 1/3 plus 1/2. That gives me 20 times 5, 6, which is 16 2/3 miles away from when he originally left. Now, last type of problems we may see are these work problems. And these problems where we're told about how long it takes an entire unit of time, we actually need to look at the inverse, the 1/t, for how much is done in 1 unit of time. And this inverse relationship is going to be helpful when we're looking at putting multiple people together to do a single job. So say it takes Sam 3 hours to mow a lawn, and it takes Allie 4 hours to mow the lawn. If they work together, how long would it take? So because they're working together, they're actually decreasing the overall amount of time, and this inverse relationship will be very helpful. So Sam took 3, Allie took 4. Together, it's going to take some time we don't know. But if we look at it as a chunk of 1 hour, that would be 1/3 of her job is done in an hour, 1/4 of Allie's job is done in an hour, so 1/t would be done in an hour. And it's this inverse component that I can actually set up for my equation. So Sam's 1 hour, Allie's 1 hour, and together's 1 hour. I add my fractions, so I got to get a common denominator, which is 12. So 7/12 equals 1/t. I can cross multiply and divide, and I get that t is 12/7. So together it would take them 1 5/7 hours, and 5/7 of an hour is about 43 minutes. So in an hour and 43 minutes, together they could mow that lawn.